Ultimately, we're gonna find the domain of each one of these rational functions. And the domain means what x's can I substitute into this equation. The only kind of numbers we're worried about substituting are numbers that make us divide by 0. Once we find the numbers that we should not use, then every other number are the numbers in our domain. Okay, so since we're just worried about dividing by 0, let's simply set the denominator equal to 0, and that's finding the numbers that we do not want to use, because anything that makes the denominator equal 0 is going to lead to us dividing by 0. Now, I'm not going to spend a lot of time on factoring here. We've been doing that a long time. So I've factored this. Once you have it factored, you set each piece equal to 0. To solve this one, I'd subtract 6 from both sides and find out x is negative 6. In this one, I'd subtract 5 from both sides and get negative 5. So keep in mind, setting the denominator equal to 0, we just found the numbers that make the denominator 0. So these are the numbers we want to exclude. Okay, so if it just says what are the excluded values, what numbers can I not plug in? Negative 6 and negative 5. Now if you want to write the domain, which is the numbers you can use, you're kind of visualizing a graph, and you're able to use every single thing on the graph except for negative 6 and negative 5. And interval notation is like reading from left to right. So starting as far left as I can possibly go, that would be negative infinity. We always use parentheses with infinity symbols. So I have parenthesis negative infinity. I can use all of those numbers until I get to the number negative 6. So I'm going to stop it at negative 6. A parenthesis leaves out the negative 6. But I'm going to pick right back up just to the right of negative 6. So I'm going to say union. And then I have parenthesis, because I'm still leaving out the negative 6 until I get to negative 5. And then at the number negative 5, I want to leave that out. So parenthesis, union. And then I'm going to pick right back up after negative 5, but leaving out negative 5. So parenthesis, negative 5. Forever to the right, which is infinity. Okay, this one here is pretty similar, but when I set the denominator equal to 0, we're finding what numbers do I not want to plug in, because I don't want numbers that lead me to dividing by 0. Here I could factor. This is a reminder, a squared minus b squared, x squared minus 5 squared, so that's x plus 5 times x minus 5. Set each piece equal to 0. This one subtract 5, so I get negative 5. This one add 5, and I get 5. You may have decided to add 25 and square root both sides, but if you do that, don't forget when you square root, you get both the positive and the negative. Okay, so nonetheless, this means the two numbers that end up making me divide by 0 are 5 and negative 5, so those are the numbers I do not want to use. I want to exclude them. And so every other number besides those can be plugged into the original. And so just visualizing that, I have every number on the number line except for negative 5 and 5. So similarly, I can use negative infinity until I get to negative 5, leave out negative 5 with a parenthesis, union, parenthesis, negative 5 to pick back up just to the right of it, through 5, parenthesis to leave out 5, union, and then pick back up at 5 and go to infinity, positive infinity, and we always use parentheses with infinities. Okay, last example is this one here. I see a fraction, so immediately I'm worried about dividing by 0. So I set the denominator equal to 0 because I don't want to use any numbers that make me divide by 0. But when I try to solve this, first off, x squared plus 16 doesn't factor. It's not a difference of squares. It's not a squared minus b squared. So if you subtracted 16 over, and square rooted both sides, you'd be taking the square root of negative 16. That's an error message. So this equation does not have an answer. In other words, there are no numbers, there's not a number out there that I can square, add 16 to it, and have it equal 0. So there's not going to be a number that I can plug into this equation and make me divide by 0. So we're not going to exclude anything because this equation doesn't have an answer. There's no numbers that will make me divide by 0. So if I'm not going to exclude any, then I can use everything. An interval notation for using everything on the number line would be negative infinity through positive infinity. If it hadn't asked me for interval notation, I could make a fancy capital R for all real numbers, which is also the same thing. Just tailing on here at the end, for people watching after the fact, I know I explained this before I started the video, but we have domain issues. There are 3 kinds of domain issues. And so if you see an equation where there's an x in the denominator, we're worried about dividing by 0. So we set the denominator not equal to 0 because these are the numbers we will exclude, and then every other number we can use. Later we'll discuss our even roots and our logarithms. But if your equation, your original equation, doesn't have an x in the denominator, an x under an even root, or a logarithm of x, then you're going to have all real numbers. I'm kind of lying because trigonometry, if there's a trig in there, that's going to be different. But algebraically speaking, that's true.